Okay, so additional examples for 4.2, so you can do the other problems. Now, we're doing linear regression, and so it's the best line of fit for the given points. We're going to round the coefficients to 2 decimal places. So we're going to actually use the program in the calculator to do this. And what we're going to do is, the first thing is, we want this in y equals mx plus b form. And we're going to go to stat, which is that middle button up here. And we're going to edit. And here I have some numbers in here already. Some of them are the same. So 1, 2, 3, 4, 5, 6, 7, that's in L1. L2, I need to change. So that's 10, 9, 3, 3, 8, 3, 2. One thing you want to do is to double check what you put in, because it's real easy to make a mistake. And you won't even know you made a mistake, because it will be close. Alright, I've double checked my numbers. Then I'm going to go back to stat. Oh, when we did the edit, we put the x's into L1 and we put the y's into L2. And somebody had an issue earlier. They accidentally deleted L2, or maybe L2 was not there. And when they went to calculate, they weren't getting the right answer. So you want to make sure that you're using L1 and L2. If L2 is not there, that's okay, use L3. But when you do that, when you go to stat and calculate, 4 and 8 are basically the same. I'm just going to pick 4. And double check that these are the same things that you put into. Okay, L1 and L2. What was that? 4. We're going to calculate. Okay, and it looks like my slope is a negative 1.11. And my y-intercept is the b 9.86. Okay, now everybody's calculator should be set to this. Do you not have the R? Okay, so that's what happens when the calculator gets reset. It will not tell us what the coefficient of the correlation coefficient is, so you have to turn it on. So what you'll do is you'll go to mode, and down here it's hard to see, but they're in blue. The stat diagnostics, you want to turn it on. And once you turn that on, then you'll see the R2. You just rerun that calculation. Okay, that's if you did not see it. So then you'd have to go back and rerun it. R is a correlation coefficient. What R does is it tells us two things. It tells us the direction of the points, if they have a positive correlation or a negative correlation, and it also tells us how close it fits to a linear equation. So the closer it is to 1, like this one was 0.7, so that's fairly close. If it was like 0.99, it's almost exactly a straight line. The closer it gets to 0, the less likely it is a line. Now, when we do this, it looks like the same points, but it's not, so I have to go back into the mode, not the mode, the stat. Not that either, stat. We're going to edit. The 1, 2, 3, 4, 5, 6, 7 is the same. But these numbers are different now. So I have to do 3, 2, 5, 9, 5, 6, and 10. Okay, I got to double check my numbers. 5, 9, 5, 6, okay. And I go back to calculate again. I'm going to do 4 again, my linear regression. And there, my R is 0.764. Okay? So that's all you're really doing on these 2 examples. You're going to have 2 with points and 2 with tables. Is everybody ready to look at the tables? Okay. So basically, it's the same thing. We're going to write an equation here, and we're going to find the correlation coefficient here. So I'm going to pause the video for a minute and let you guys work on this. Okay, did everybody get this 0.51x minus 0.36? And then on number 12, 0.812. So that one's more of a straight line than the other one. Okay? All right. Let's go ahead and start chapter 5. Transformations of functions is what the first section is about. So basically, what do you do to these functions? How do they look on the graph without just typing it all in? So here, it says you're going to compress it vertically by a factor of 1/4. So in other words, I'm taking this function, square root of x, and I'm going to multiply it by 1/4. That's the compression. Usually you see it in front, though. Reflect it with respect to the x-axis. So that means instead of a positive y, now it's a negative y. So that sign is kind of on the outside. If it's a reflection about the y-axis, that would be in the parentheses. Okay, the next thing is it's moved 2 units up, so that goes, the vertical shift up is on the very outside, so the last thing that you do. So now I'm going to look for a function that looks like this. So I know it's not any of the 4s. It's not negative inside. It's negative outside. So it's this one. Okay? All right, now, I'm sorry, what? The 4 doesn't get promoted? No. No. It's only the positive negative flip on the actual value. Okay. Now, these problems are inherently long. So what I did is I made it so that you can fold your paper like this, so you can see the whole problem together. You can't really see it all on my camera. But you can just fold it like this, like a book, and we can see the whole problem. So there's a few of them like this. So here I have a function, and it says, determine the more basic function. So in other words, what am I doing just to the x? Yes. So x squared is like my parent function or my basic function. And then what does that look like? X squared.
Oh, yeah.
Yeah, on the graph. So it's one of these. Remember, isn't x squared a parabola? Yes. Okay, remember all these. This is like a cube, maybe even a 5th power. This is 1 over x. Do you want me to write these down? This is 1 over x squared. It has to be an even power because it's keeping everything positive.
That's nice.
This. Did I write it too sideways? Sorry, it's x's. Oh no, it's a 1 over x. This is like a square root of x. Because remember, I can't have negative. This is like a cube root of x. I can have negative. This is, of course, the absolute value of x, which is just those straight lines. And then this is just x. Okay, so what did we do to this parabola? This poor little parabola. Is there a horizontal shift? No, because there's nothing inside parentheses here. Is there a vertical stretch or compression? Yes, I'm dividing by 3, so I have a compression. I'm going to write it 1/3, not negative 1/3, just 1/3. Is there an x-axis reflection?
Yeah.
Yes, that's that negative on the outside. Is there a y-axis reflection? No, because there's not a negative on the inside. Is there a vertical shift? Yes. On the outside it is -3, so we're going to say down 3. Okay, we good? Now we get to graph it. So when I'm graphing these, what I like to do is make a little table to kind of help follow where these points are going with all these transformations. So I have x, my input, I have my parent function, x squared, and then I have my transformed function, just negative x squared over 3 minus 3. Okay, in this instance, if x is 0, x squared is 0, and then this part would just be -3. Do you see that? I have 1 input, 2 outputs. And I'm trying to get them to fit on my graphing window, which is just a 10 by 10. X could be 1. When I square it, it's still 1. When I square this, it's still 1. So then it's 1/3, which is negative, because that sign's on the outside. And these together is just a 3 and 1/3. -3 and 1/3. That's okay. I try not to get fractions when I can, but sometimes they're there. Now, I'm dividing by 3, so it's a clever point to pick to get an integer back. 3. So 3 squared is 9. And then here, I've got 9 divided by 3 is what? 3. -3 minus 3 is -6, right? Okay, now I can graph both functions. So I have 0, 0, 1, 1, and 3, 9. You can use symmetry to graph these. Oh, I want to graph both. That way you can see how it's transformed. I'm going to... Ask me again later. I think they're going to ask you just to graph the transformation. So when we do this, I'm going to show you in a different color what's going on with this. I have 0, -3. 1, a negative 3 and a third. So it just went down by a third. And then 3, negative 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. And then symmetry. And that's enough points to graph it. So you can see it has a reflection. Oops. And it's wider than it began with. And then, of course, it was shifted down. My new function, what is the domain of this? Is x restricted? No, x is still not restricted. But y is. Less than or equal to negative 3. And to write that in interval notation, I start with the lowest point. What's the lowest point this function can have? Yes, negative infinity. And the highest point? Negative 3. Do I include negative 3? Yes, so I use the brackets. Okay, so your program, when you start typing this in, some of you have already noticed, you put this parentheses in, it'll automatically close it for you. So you're going to have to look in the menu and choose which one. This one was open, close. And all of these selections are in the menu on Hawks. Okay? All right, let's do this one. Okay, on number 3, what am I doing to this x? Yes, I'm taking the cube root. All these other numbers, these are just transformations. They're not changing the actual shape of it other than making it smaller, larger, shifting it around. Okay? Okay, so the cube root of x, which one is this? You mean, yeah, third column, second row? Yeah. Yes. So I remember the roots are kind of flat looking, and then the exponentials are the taller ones. Okay. So looking at this parent function, I know that my domain and my range are both going to be what? All reals. Okay, good. So then I want to go, okay, what did I do to this function? Is there a horizontal shift? Yeah, it's the opposite. It's moving right 3. What about a vertical stretch? It's that 2 on the outside. Yes. What about an x-axis reflection? No. Why? No. Because these are negatives in front here or in front there. Okay, vertical shift. Yeah. So they use the same number for the horizontal and vertical, but I just want to show where I'm getting them. So it is up 3. Okay, we're going to graph this bad boy and then work on 4-2. So, again, I can make a table. And this one's different from the one before because I do have a horizontal shift. It's hard for me to pick the same x values because my x value translated 3 units to the right.
Do we have to include just one?
I'm doing that so I can show both. And then I'm going to actually do 3 more points on the horizontal translation. So like the x values that I would pick that would be easy, x could be 0, x could be 1. What can I take a cube root of and still get an integer value? 27, but 27 won't fit on the graph. 16 is not a cube. 8. Oh, yes. Okay, so the cube root of 0, cube root of 1, cube root of 8. Okay? Now, this is what I'm going to do. You know it was shifted 3 units to the right, correct? So I want to shift these 3 units to the right. So 0 plus 3, 1 plus 3, and 8 plus 3. It's just going to be a little off. I'm doing this so I can get integer values back. Oh, because this is just for the parent function, and then this is just going to be for the other one. Okay? So, looking at this, 3 minus 3 is what? 0, and 0 plus 3 is? Okay. 4 minus 3 is cube root of 1. 2 times 1. 2 plus 3. Okay. And then 11 minus 3 is 8. Cube root of 8. 2 times 2. 4 plus 3. Okay, so now you know why I shifted these, because I wanted to take those cube roots and still have numbers that I like. Okay, so remember the cube root is that flat one. You've got 0, 0, 1, 1, and then 8, 2. Okay, we've got nice symmetry here. It's looking kind of flat. So this 0, 0, the center of this function where it has the point of inflection, shifted from 0, 0 to 3, 3. Okay? So think of this as my new center. So whatever I do going to the right, I'm going to kind of move in an odd way to the left. Okay? To keep it symmetric with this point. So 4, 5. That means I go over 1 and up 2. So over here I would go over 1 and down 2. Do you see? It's not a linear line. It looks like it, but it's not. Because remember, this is my new center. Then I have 11, 7. 11's kind of over here in the arrow. 7 is 3 from the top. Okay? So that meant I went up 2 and over 7. So I'm going to go down 2 and left 7.
I'm so confused. What is happening?
Okay. These are the 3 points that are on my table. You got the 3 points that are on the table?
Yeah.
3, 3, 4, 5, and 11, 7, right? These points from the table only translate to the right part of the graph, okay? But there's a left part of the graph. I didn't put it on the table. I'm just using symmetry to plot them. So like here to here I went up 2 over 1. So now I'm going to go down 2 over 1. And then here I went up 2 over 7, so now I need to go down 2 over 7. So however I moved it this way, I'm mirroring on the left side. Okay? And it looks really odd when I graphed it with the other one. But just remember, this is your new center. Okay, we already said it was all rules on both. And so this is probably the one example that just kind of looks really odd, but that's okay. It's an odd kind of function.